Hello everyone, good afternoon. My name is Ricardo Quinones, and I have been asked to provide a presentation on problem solving strategies in the hopes that future teachers or current teachers can use these strategies I provided in positive ways when teaching in a mathematics classroom. Right, so let's get started. So I have here the contents that I'll be talking about. First, I'm going to define what problem solving is, and then I'll provide some strategies that can be helpful that involve problem solving. I have them listed right here. I'll be talking about them later. And then at the end, some references for in the case that you want to search information on these. So first of all, what is problem solving? So here I have a definition. Problem solving can refer to when you have mathematical tasks that have the potential to provide intellectual challenges that can enhance students' mathematical understanding and development, right? According to Kai and Lester. It involves applying mathematical concepts and reasoning to find solutions to unfamiliar problems. And a problem, right, it should be interpreted and analyzed to effectively find an valuable solution. So, right, the idea of problem solving is that you have an engaging task or a challenging task that allows or allows students to um, think about the problem, understand the problem, and then solve it, right, productively. And then here, what to consider when problem solving, right? There are some things that you have to consider when going through this process. I provided here some helpful, tips, right? We have productive struggling, which has been proven to be very useful by the National Council of Teaching Mathematics. Students should work to make sense of the situation and determine a course of action for solving the problem. So productive struggling, what I mean by this is that you have, when you present a student with a problem for them to solve, you can't just give them the answer right away, right? You want them to think about the problem, you want them to construct ideas, possible solutions, you want them to really think about it and then build conceptual knowledge, if you will, which leads us to the next point, conceptual understanding and procedural fluency. You want the students to understand the main content first before proceeding to create a process for solving the problem. So, right, again, you want them to understand the content so that way later they can come up with efficient and fluent procedures that can effectively lead them to the solution, a correct solution of the problem. And then third would be making connections with representations. So students should be creative when problem solving by visualizing and utilizing models to describe problems. So later on in the presentation, I'll be talking a little bit more about these visualizations, but the idea is that you have, for example, if the students have a problem that involves an equation, instead of just doing the algebraic procedure and getting to the solution, you can also, for example, use graphs, right? An equation, you can visualize it by writing, drawing, using tools to create a graph, and then you can read the same answer. And then some students could find that more useful because they can visualize how the graph works, the reasoning behind it, and making these connections with the original task, right? So the first main strategy that I want to talk about, it would be Polya's four-step problem-solving model. Is a very effective model, I would say, that has been used in different fields. This model was created by George Polya. You can see the picture of this scientist right here. Like I said, this problem-solving model is not exclusive to mathematics problem solving, but also, for example, cognitive psychology and any other field that involves problem solving. And then the main four steps of this problem solving model would be understanding the problem, devising a plan, carrying out the plan and checking each step along the way, and then finally looking back and examining the solution. All right, so I'm going to talk a little bit about these four steps. First, you have understanding the problem. So this means that a student should not proceed to do constructions or computations without first having understood the problem at hand. So it connects to conceptual understanding, right? The student should know what the problem is talking about before proceeding to do the process. According to Polya, right, it is foolish to answer a question you do not understand, right? And then the problem should be clearly identified and sought before solving. The second step would be devising a plan. This means, according to Polya, finding a connection between the data and the unknown. The idea is that students can, after understanding the problem, they can consider various strategies for approaching the problem, such as trial and error, retracing steps, visualizing via diagrams, etc. Right? Just trying to find, right, connecting to the conceptual understanding. Now you have the procedural fluency. So just coming up with these procedures according to what you understood to finding the problem, the solution to the problem. The third step would be carrying out a plan. So after devising a plan, the students can implement appropriate strategies in a careful manner. And right, it is important to make sure to recheck each previous step along the way. So pretty much making sure that each procedure you are doing is coherent and according to the original problem. And finally, the fourth step would be looking back and examining the solution. So in this step, the students review their solution and check for any errors made along the way. The solution should be appropriate and consistent with the devised plan. And then when examining the solution, students should think about alternate ways on how the problem could have been solved. Right, so after they finish and reach a conclusion, they examine it, make sure everything is correct, and then they look back thinking of, for example, if they did it one way, they could have probably done it another way, just like looking for different ways the problem could have been solved. And here, the second strategy I want to talk about is group collaboration, very self-explanatory. It is a promising strategy that draws upon various social and cognitive skills, according to Fellmer. Group collaboration allows students to view different perspectives from peers when approaching a problem, and then they use this new information to come up with a new problem, new strategies for problem solving, right? So you have in a group, you have different perspectives, people coming up with different ideas. Let's say I give an idea of how I solve the problem, but then I hear from someone else and I didn't know anything like how about that approach. So it can open like many ideas, many perspectives on thinking when solving that problem. And right, the groups can be consisted of smaller, compact groups. So let's say if you have a group of 30 students, right? If you have a class of 30 students, you can have them, for example, groups of 3, 10 groups of 3. Or you could have a bigger but diverse and unified group. So this could be either splitting the group, for example, a group of 30 into 2 groups of 15, or a whole class discussion where the teacher asks the students to provide their thinking. Group collaboration, right, also develops deeper mathematical understanding in the process when comparing and contrasting strategies, and right, it promotes creative thinking and ownership of ideas. And then some mini strategies for problem solving that involve collaboration. You can see think, pair, share. It is when you have when you group different students. Well, before grouping, you have them think about the problem, then you pair them with different students, and then they share their solutions. You have the jigsaw method. When you have a main problem, you divide it in different like jigsaw puzzles, and you assign different groups to those jigsaws for them to focus on that aspect of the problem. You also have problem-based learning, which we've heard of before, PBL. And then we have group discussions, similar to what I said in the previous slide, is when you have a whole group discussing, sharing their ideas, sharing what they found when problem solving. The third strategy I would like to talk about is the use of technology, right? Technology right now being very prevalent. For example, right now, right after the COVID pandemic, technology has been very prevalent in when it comes to education, and then right mathematics education. But we know that even before the pandemic, technology has always been prevalent, so it can definitely help us with problem solving. Using technology tools can provide dynamic, interactive, and personalized experiences for supporting students in problem solving. And then some ways technology can aid in problem solving is by providing visualizations of real world problems for ease in making connections. You can simplify calculations and provide immediate feedback for problem adjustments. You can allow students to interact with engaging activities that promote critical thinking and strategy development. And right, according to Desai and some other researchers, it can support students in gaining deeper understanding of concepts such as geometry. So these researchers, they made a study where they used if I remember, they used GeoGebra in a geometry class for the aid of student thinking when it comes to mathematics, and GeoGebra definitely helped them in solving these problems. And then here is an example of a graph, a sine and cosine, where it represents, right, we can see the visualization of sine and cosine and how it connects to a circle, trigonometry, which can, make students connect these two, like the representation with the mathematical content, and it can ease their problem solving. Some technological tools that I've heard and used are Desmos, which is mostly used for graphing, as I showed you on the previous slide. There's GeoGebra, which is mostly used in geometry with 3D figures. There's also, for example, I provided Stack, which I haven't used, but I've heard of before. There's also Wolfram Alpha. I also provided here educational platforms such as Canvas, Moodle, where you can create different assignments for students. And of course, as of recent, we have artificial intelligence. The main example being ChatGPT, where you can ask the artificial intelligence about pretty much anything. You can ask them any prompt, and most of the times it provides a very surprisingly accurate answer, right, from different sources online. While this is very helpful and it can help you in easing, right, the problem solving process, it is also negative in the fact that for the consequences, it can lead to an over dependence of technology, and this can lead to a lack of student reasoning when problem solving, which again is very it's a critic how do you say it, like a critical thing to think about, because right, we want these technology tools to help us as a supplementary tool. You don't want the technology to do the work for you, right? At the end of the day, we are the ones doing the problem solving, not the technology. And also another consequence would be that technology changes rapidly, so it is necessary to constantly adapt them to our teaching methods. So again, we know that artificial intelligence was very recent, so for some like lessons and classes, it has been implemented recently, but it wasn't as effective or as prevalent, let's say, 3 years ago. So we know that technology can change really fast, so it is important to adapt current technologies to our curriculums, so that way they keep this coherency with our lessons for the students. And then the fourth strategy I want to talk about is the flipped classroom. So a flipped classroom is a concept or an idea, right, a strategy that it goes kind of like the opposite of what you would see in a traditional classroom. So an inverted or flipped classroom instructing approach, right, is again different to a traditional approach. Instead of exposing students to new topics and materials, the students instead have access to the material before the class, with the purpose of promoting discussions in the classroom. This could be via videos, documents, online materials, anything that the teacher provides as supplementary material. So the idea is that instead of having the teacher start the class, teaching, going at their own pace, and then the students doing exercises, the idea of a flipped classroom is that the teacher gives students supplementary material for them to read, practice at home, or before the classroom in general, so that when they arrive to the classroom can be used as a discussion group or discussion area where the students are the center of the learning goals. If used properly, this is a promising pedagogy with many benefits in mathematics and problem solving in general. So, as I mentioned before, right, one of the benefits is that it places learners at the center of the learning goals. Obviously, it promotes self-paced learning among students, so they have their own time um, to read and to adapt to the new material. And it is applicable in many different environments, such as face-to-face, online learning, and blended learning, where you have both face-to-face and online combined, sort of like a hybrid. But again, it could have some consequences similar to technology, where for the students, it requires them to complete supplementary material before the lesson. So if they're not organized enough, if they have outside factors affecting them and not allowing them to complete the material, it could lead to them getting lost during the flipped classroom discussion or not knowing exactly what the lesson can be about. So it requires input from the students, and it also requires input from the teachers. By adapting to, they should adapt to new technology to do teaching methods, which could be difficult at first, right? If you're a teacher that is used to traditional teaching approaches, then this new teaching approach could be, since it would be new, it would be difficult to implement at first, right? But then again, with enough practice, teachers can easily adapt this to new to their lessons, right? And it could be very, very beneficial for students, especially when problem solving. Right? And here are the references if you need them or if you want them for any further information. And yeah, I really hope this presentation helped you consider problem solving in your classroom. Right? It doesn't have to be right away, but by checking these strategies, you can slowly apply them to your lessons. And yeah, hopefully they can become effective to you in many different ways. Right, so thank you very much and have a good day.